Alright, now we're testing the diode. So now the device under test is this diode. You can see the silver band that indicates the N side, and that's kind of like, it blocks the current. So we have positive to negative, things will flow, and we have a 10 ohm sense resistor. So we apply and measure voltage 1, and we measure voltage 2, and because this is only 10 ohms, we're kind of assuming the voltage across the diode and the whole device is the same. Now, I happen to like using sine waves, but really one should use ramps for this kind of thing. But notice we're not getting the triangle wave at the top, and we can go to add measurements and take a snapshot and see that the max is around 700 millivolts and the low is about 1 volt. And what's going on is that we're getting a lot of current flow, right? So this voltage is representing current, and notice it's getting sharper, and so the whole device is getting a resistance that's getting smaller with voltage, and the function generator just can't keep up. So really about 700 millivolts is all we can get. All right, we'll just clear everything. Okay, so let's go to acquire XY, and here we have our diode curve, and we can try to center it as best, center the curve as best we can. Okay, and that's when I zoom in like this, it does look like a model where it turns on almost instantaneously. And when I zoom out, you can see that there's a kind of an exponential, and then it's being limited by a series resistance. So that's a diode, and it's, to analyze it further, it's best to take the data, save it as Excel, we put it in a USB, and then analyze it for later. Probably can't get I don't want to look at the reverse breakdown, but just let me reiterate. Okay, this kind of curve is more the diode equation with the exponential term, right? And when I do this, right, it's more no current in one direction, infinite current in the other. So just, excuse me, sometimes models are just how you look at it.